Welcome to the Secret Underground Laboratory Recovery and Salvage, where rude mechanicals do magic. Hello, I'm Bronze Age, Director of the Secret Underground Laboratory, and today we're going to talk about a labor-saving device that took a lot of labor to build. Chandeliers tend to be big and heavy, or big and delicate. Either way, it's sometimes difficult to handle. And when I've got one here on the bench, then the bench is basically inaccessible for anything else, sometimes even just getting into the drawers of the cabinets. So I thought the solution would be a rail trolley, which could move the work back and forth as needed, get it out of my way when I wasn't working on it, and bringing it in close when I was. Now this video may turn out to be a little disjointed because when you're designing something like this and building it as you go along, there's a lot of dead ends and pieces that have to be remade because it doesn't always work exactly the way you thought it was going to, or more often halfway through you discover a better way to do it. The need to make a round piece of wood out of a square piece of wood comes up fairly often in the lab. Usually it's the base for a lamp, or more often a floor lamp. For small pieces we can use a lathe, but most of the time we need a bigger piece than the lathe can actually handle. And up to this point I've had this nifty little jig. Now jigs like this have been around since there have been table saws. It's just a sled that slides in the miter slot. And in this case, you take a piece of wood, put a hole in the center, put a pin through it, and just slide it through the blade each time, taking off another corner, going round and round, and you will get a very accurate round piece of stock. This jig is actually made for the most common sizes I need, but it can't go all the way out to 24 inches. The problem I've came up with when doing these wheels is that the nail in the center method like that just wasn't accurate enough. The problem was the pin and the nail just allowed too much wobble back and forth, so that this diameter and this diameter and then the diameter that the bearings get pressed into, none of them had the same center. And the result of that was a wheel that just wobbled too much. One wheel by itself, not too bad, but when you've got four of them trying to work together, they work against each other, and it creates just too much friction on the trolley. So something better had to come up. I'm drilling the pilot hole with a 3/32 bit. I clear the chips about every 1/8 of an inch of travel to keep the bit from veering off center. This is the third set of wheels. The bore for the bearing is made with a Forstner bit. A small straight pilot hole ensures the bearing bore on both sides is on center. In addition to drilling the holes more precisely, I had to come up with a much more robust jig. Not only is this jig more robust, made from a very thick slab of plywood, but the actual centering for the wheels is the wheel bearings. That's what will hold it in place as it goes through the saw. There's two things to be careful of when you're using this method. First is a lot of these little wedge-shaped pieces are going to pile up behind the blade, and it's possible possible for it to get into a bind as well as get shoved down into the clearance plate. And throw all this back in your face. So have to keep the table clean. Also, at the point where you're doing the turn like that, you're no longer actually sawing, you're more of a milling. And too much lateral pressure on the blade will deflect it, and you'll get an irregular shaped piece. So you have to engage just a few of the teeth at a time, pushing it forward as you go up the side of the round until you get all the way to the end. Being very careful not to actually push the blade over. Now to cut the rolling rabbit, adjust the blade down to the desired height and shift to the second position. Now, on this kind of a cut where the top of the saw blade is going to be inside the board, you can't cut corners off and just keep going around chipping away. You've got to make a single curve and then move it just a little bit so that you're going one blade width across each time. The reason for this is if you start making random cuts through it, you end up with sort of like a comb effect with all these pieces sticking down. They'll break off, they'll chip, they can break the whole thing, and just make a general mess of all of it.
The axles are made from 1/2-inch steel rod with 1/2 by 13 threads cut on each end. This is pretty stiff work as far as it goes in the lab. Most of the threading I do is in brass or bronze, and it's seldom anything this large. The first problem is holding it while I cut the threads. I've set up this pipe vise which doesn't have much grip on the rod, so I made a set of jaws from water pipe and still had to line them with emery paper to get enough friction to keep the rod from turning. I start the threads with a regular die wrench. The rod has a pretty steep chamfer on the end, so the die can get some grip and dig in. Getting the thread started is the most tedious part of the job, and it has to be done 4 times. Now it's time to get more leverage with a long wrench. To keep the rod from turning in the vise, I had to turn a little, break the chip, add a little oil, and keep going for 23 turns. This is a little longer than needed, but I can cut the axles to the right length after it's all together.
Now all of it goes together to form this trolley with the hook on the bottom of it. Now end play is set with these nuts on the axles just the same way that you would with the wheel on a bicycle. This inside nut on each side is tightened down until I get the right amount of clearance, and then the outside one clamps down on the side piece to hold it in place. And all I have to worry about is that each one of them turns freely. So, testing phase 1 is complete. Okay, test phase 2 complete. The last piece I need for this to work is some sort of brake to keep it from rolling back and forth down the rail while I'm trying to work.
The lock pin is made from standard hardware pieces. It's a 3/8 steel rod with a washer welded as a spring stop. I threaded each end to take an anchor nut and the ring. The ring is a big lock washer with a nut welded on. The spring force is a compromise between holding the trolley in place and being easy to release. There's a hole at the end of the rail to give a positive stop to keep the trolley from hitting the support rod.
One of the fun features of working on a chandelier like this is that when it's hanging straight, it's too big to go through any door. So that means it's got to be hung from this rack at an angle. And that has always been a real pain to try and do, especially with something big and bulky like this. But I believe the rail trolley is going to make all the difference in the world for this kind of thing. So at this point I'll have to call it a success. A few obvious improvements have been made. First off was the stop collars to keep it from rolling all the way through the block. There's one at each end, and to control the height of whatever's hanging, I've got another stop collar on with a hook on it. It goes through like that. Now there may be some more improvements to come, maybe a block arrangement, get a little more mechanical advantage, but I'm not sure that's going to be really worth the time or trouble because none of these chandeliers are that heavy, just awkward to handle. So, this is Bronze Age for the Secret Underground Laboratory, and I appreciate you sticking around long enough to watch me reinvent the wheel several times over. I'd appreciate it even more if you would like and subscribe. Tell all your friends, tell all your family. If you have any questions or comments, or you think I'm risking my life standing underneath this thing, put that in the comments. I answer all the comments, and I do like to hear from you. So, thank you very much, and I'll see you next time.